Okay, guys. So last week we talked about, or I guess yesterday, depending on when you're looking at this, we talked about some complex numbers. And today we're going to talk about things that we can do with complex numbers that you can do with real numbers, like add, subtract, and multiply. Okay, so this is a review of what we did. We simplified some powers of I. And if you remember, it was a cyclic type of relationship. So only 4 outcomes could happen. And we were trying to see how many I squareds were hiding. You would change I to the 12th to I squared to the 6th power, right? So that would be -1 to the 6th power. You have an even number of -1s. That would give you a +1. On this guy, what you should do is kind of pause these and work them to see if you get the same thing I do. The negative is going to give you an I, so that will be an I. And then you still have the square root of 144, so that would be 12. But the way we're going to write it is 12I. And then if you remember, this is a complex number. It has a real part and an imaginary part. So the real part would be just the -5. And that's that A part that we're talking about. And B is the imaginary part. That's the part in front of the I, including the sign, and that would be 3. So, like I said, we're going to be looking at these different operations that we can do with complex numbers. And they're going to talk about the properties of complex numbers that hold true, similar to the properties we learned earlier this year about real numbers. And we're going to add, subtract, and multiply. So complex numbers, A plus BI, we are able to add them, subtract them, and multiply. We can divide them as well, but we're not going to talk about division today. It's a little bit more complicated, so we'll probably talk about that later. So properties of complex numbers. These are called the field properties. And just like real numbers, that would be the field properties of real numbers. And basically, a lot of the same stuff holds true. We can still do commutative property. We can still do associative, which is where the grouping symbols happen. Distributive property, identity, we can add 0 to it and it won't change anything. And the inverse means we can undo it. And this is the additive inverse and this is the multiplicative inverse. Basically, because the properties all hold true, what you're able to do is you're going to like combine the real parts and combine the imaginary parts. So basically, you almost will treat the I like it's a variable, like it's an X. And you'll just combine like terms. You'll combine imaginary parts with imaginary parts and real parts with real parts. And the only thing you'll be really careful of is looking for these I squareds, because if I squared show up, we'll need to change those to -1. But other than that, everything is very much like if it was a variable. So here is the first example. They want to know what property allows this to happen. So here they took 2 complex numbers and were adding them. And then look what they did here. They moved this guy first and then this other guy second. So this would be the commutative property, which changes the order. And what's happening here? We have 3 numbers. And they put the brackets around the first guys first. And over here, they put the brackets around the second guy. So that is associative, moving the grouping symbols. And here they took AI plus BI and they pulled out, what are we going to do? Which one of these is going to be the same? Let me move this so you can see. Which one of these is the same as AI plus BI? Well, what you can do is you can backwards distribute this, like the distributive property. And you can pull out the A plus B and then just leave the I afterwards. Or you can say that the I is like a common factor almost, and that's the A plus B. So that would be the distributive property. So I'm just going to show you what this will look like when you add them. These parentheses are kind of not required, but they kind of are, because this is one number plus another number. So when we add them, we're just going to add the real parts, the 3 and the 8, which will give me 11. And then you'll have a 7i and a -6i, which will just give you 1i for the imaginary part. Same thing here. 8 and the 3 is 11. -6 and 7 is +i. When you're adding 3 numbers, we already have these 2. We know what that is. That is 11 plus I. And now we can add it to the 1 plus 9i. And we'll just add the real parts and you'll get 12. And the imaginary parts and you'll get 10i. Here, you will just get A plus BI. But if it was like a 2i and a 3i, that's really the same thing as 5i. And that's what allows us to add the imaginary parts. So it's basically just combining like terms. So let's practice. You can pause if you feel good, or you can watch me first and then try on the next one. All we're going to do is put the real parts together, negative 12 and 9, that's negative 3. Then the imaginary part, so you have a 4i and a negative I, that's a plus 3i. Put the real parts together, 3 and negative 2 is 1. Negative 5i plus 8i is 3i for the imaginary part. And then on these two, you have a 3 and a negative 2, which is a 1, a negative 5i and an 8i, which would be a positive 3i. So these two are the same. And I don't know why I wrote it down twice, but I did. So that is strange. Okay, what about if you subtract? Well, if you subtract, it is not any different than if you would subtract an expression. What you need to make sure you do is you need to subtract the real part and the imaginary part. Okay, so like you'll have to kind of distribute that negative because you're going to have to subtract the real part and you're going to have to subtract the imaginary part. So what are we going to do? Well, this will be the same thing as 10 minus 3i plus 6i minus 7i. Because you're going to subtract a negative 6, which, oh, that's not an I, excuse me. Subtract a negative 6, which is 6, and then subtract the 7i. So 10 minus a negative 6, same thing as plus 6, which is 16, and then you have a negative 3i minus 7i, which is negative 10i. So just subtract both parts. And let's try this one. 5 minus 2i minus 1 plus 8i. So subtract 5 minus 1, that would be 4. Negative 2i minus 8i will be negative 10i. You also could rewrite it. 5 minus 2i, you can write a minus 1 and a minus 8i and combine it from there. So which property allows you to write the expression this way? That would be the distributive property because you're distributing that negative 1. What is the real part of that difference? So what was the real part? That was what we got here. That's the 4. The imaginary part is the negative 10, and the entire difference is 4 minus 10i. Okay, what is an additive inverse? Additive inverse is what gets us to 0. So you're going to take the opposite of the real part and the opposite of the imaginary part to get to 0. So the additive inverse of negative 2 plus 8i, well, what would get rid of the real parts? That would be 2. What would get rid of the imaginary part? That would be a negative 8i. So 2 minus 8i would be the additive inverse. And when you add them, you'll get 0. How about when you multiply? Well, when you multiply is when you have to be a little careful. That's when the I squareds are going to come up, and we'll have to change those to negative 1. So what happens when you multiply 3i times 4i is you'll get 12i squared. But you know that I squared is negative 1, so that's the same thing as negative 12. So when you multiply two pure imaginary numbers, you end up with something real. What happens here? Well, they're kind of explaining it here. They're writing it like this: 0 minus 2i and 6 minus 7i. And then it looks like they're going to be foiling or double distributing, which is fine. And they got 0, and they got another 0, and then they got a minus 12i, and then this is what happens. They got a 14i squared, which is the same thing as minus 14, and they wrote it in the a plus bi form. Let's see what happens if you do it just one distributed step. That would be negative 12i plus 14i squared. I squared is the same thing as negative 1. So negative 12i plus 14 times negative 1. Most kids don't write that out. Most kids will just cross that out and write negative 14, negative 12i minus 14. We probably should rewrite it in the correct form, a plus bi, and then we'll get the exact same thing they got here by double distributing, by writing this pure imaginary number as a true complex number with the real part of 0. So it's a lot easier just to distribute once, but you're also welcome to double distribute and change them both into what looks like a complex number. So let's go ahead and try double distributing here. This is a complex times a complex. They both have real parts and imaginary parts, so we will have to double distribute. 8 times 3 is 24. 8 times negative 7i is negative 56i. 4i times 3 is plus 12i. In here, be careful with sign, you get minus 28i squared. That I squared is -1, so that changes this to plus 28. Let's do the real parts first. 24 and 28. That gives you 52. And now for the imaginary parts, -56 plus 12. That gives you -44i for the imaginary part. Go ahead and try this one. You can pause it when you get it right. 2 times -1 will be -2. Then you'll have a plus 8i. Careful with signs here. That's a plus 7i and a minus 28i squared. That minus 28i squared becomes a plus 28. -2 plus 28 is 26 for the real part, and a positive 15i for the imaginary part. So that's how you multiply complex numbers. Okay, now complex conjugates are kind of cool. When you multiply complex conjugates, math magic happens. So what is a conjugate? Well, a conjugate is something that's not quite the opposite. They're not additive inverses, but they just change the second sign. And you have seen this before when you did the sum, and the difference of two squares. This is the difference of two squares, which factors to 7x minus 2 and 7x plus 2. They're conjugates. They have the second sign is different. And remember what happens when you multiply conjugates? The O and I of FOIL cancels out, and you're left with something simpler. Well, what happens when you multiply complex conjugates is you end up getting something real. So watch what happens. 7 times 7 is 49. We usually won't write this step because we'll know that they should simplify, but we'll write it this time, minus 14i plus 14i. And that's happening because they're conjugates. Then you get a minus 4i squared. So these cancel out. Minus 4i squared is the same thing as plus 4. And you get a real number of 53 when you multiply those two complex conjugates. So go ahead and try these next two and see how you do. 3 times 3 is 9. Minus 24i plus 24i, that cancels out. Minus 64i squared, that becomes a plus 64. And if you take 9 plus 64, you'll get 73, a real number. 4 times 4 is 16. Minus 20i plus 20i, and then minus 25i squared, which becomes a plus 25. 16 plus 25 is 41, and I'm almost out of space. You can barely see it. All right, and that's it for the notes. I told you it wasn't much, and you can look over the homework in the quiz, and that's all for this weekend.